there are certain features of a function that we really care about, and these we should be able to identify. When we look at a graph, we should be able to find these features of a function. So for right now in Algebra 2, we're just looking at the graph and finding these from a graph, okay? So first things first, we're going to look at increasing, I'm going to go on the other side. We're going to do x-intercept and y-intercept. So x-intercept means where it crosses the x-axis. These are also called the zeros. They're also called the solutions. But really, all it is where does it cross the x-axis? So we're just going to find the number where it crosses the x-axis. Well, this function crosses the x-axis right here, and right here. So what are the numbers where it crosses the x-axis? The x value where it crosses the x-axis is -3, -1, and at 4. So I want you to think of this as kind of like a graph over time. And think of this as like a roller coaster, right? And at time equals -4, we were here. And then we go through this roller coaster and we end here. And you're like, well, time can't equal -4. Well, let's think about time equals 0 is noon, okay? So this would be 4 minutes before noon, 3 minutes before noon, 2 minutes before noon, 1 minute before noon. And this is like a special fancy roller coaster that goes underground. That's what this is right here. And so we're like, hey, where does this roller coaster go below the ground? Well, at time equals -3, it goes below ground. At time equals -1, and at time equals 4, it went below ground. So that's that's our x-intercept. What about our y-intercept? Well, that's where it crosses the y-axis. So that would be right here. What's the x value where it crosses the y-axis? Not the x value, the y value where it crosses the y-axis, it would be at +1. So it crosses the y-axis at +1. So the next thing we're going to look at is positive and negative. It's another thing we need to know about functions. We need to know where they're positive. So we're thinking of this as a roller coaster. Positive, when I say where is the function positive, I mean where is the y value positive. Anytime we say the function, we mean the y value. So the idea is positive means where is it above ground, and negative means where is it below ground. Okay, so where's this function above ground? Well, it's above ground right here, and it's also above ground right here. Okay, so at what time is this above ground? Well, from -4 to -3, it's above ground. And then also from -1 to 4, it's above ground. So we're just for now going to write it just like that. We're not going to use any fancy notation. This is called interval notation. And there's another video on that. But it's above ground for those two intervals. When is it below ground? When is it negative? Well, it's from here to here. So what time is it negative? -3 to -1. All right, let's look at increasing and decreasing. So for increasing, I think of this as at what point is the roller coaster going up, and at what time is the roller coaster going down? So if I was riding on it, when would I be going up? Well, I'd be going down, 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 down. And then right here at time equals -2. So at -2, I start going up, and I stop going up at 2. So right here, going up. Where am I going down? Well, from -4 to 2, and from 2 to 4, I'm also going down. And you notice I use open brackets for all of these with my notation. Increasing and decreasing are always going to have open brackets. They just are, always. All right, these ones, domain and range, they sound so hard, but they're not. The domain, just like our song says, the domain is the input. What are we putting into our toaster, right? And what values can we put into our toaster? So I look at this and I say, there's nowhere on the function that is less than -4. And there's nowhere on the function that's greater than 4, right? This roller coaster only goes from 4 minutes before noon to 4 minutes after noon. It's a really slow roller coaster. Very boring. But it only goes from those 2 points, right? So our domain, we say, what's the farthest left? What's the lowest value? I should do that in red since domain is written in red, right? The domain, I'm going to draw a line at the farthest left value, and then I'm also going to draw a line at the farthest right value. How far can I go left and how far can I go right? So our domain goes from -4 to 4. Now what's interesting is, do I include -4? No, because see, it's got an open circle, which means I go all the way right up to 4, but I don't include it. But do I include 4? Yes, there is a point at 4, right? There's not a point at -4, but there is a point at 4. So my domain is -4 to 4, but I include 4, so I use that closed bracket. Now range is the same thing, but for the y values. So I say, how low does it go and how high does it go? What's the lowest possible value that it takes? The lowest possible value is right there at -1. And I include -1 because there is a point at -1. And what's the highest possible value it takes on? Well, it takes on 3, and it also has a point there, so I include that. Just because the point isn't drawn in doesn't mean the point doesn't exist, right? This one's drawn in because it's an endpoint. But right here, there is a point right there at 2, 3. So you see I just drew a box around it, basically. Domain and range, that's all you do. You draw a box around it. You find the farthest left, the farthest right, the top, bottom, and the top. And that's your domain and range. So remember, range, y values, or output. Domain is x values. What x values can I take? All right, last but not least, there's average rate of change. Average rate of change just tells us how much did the function change over time. So if I want to say, what's the average rate of change from -4 to 4? How much did it change over time? Well, at -4, we're at 1. And at 4, we're at 0. So I'm from the point -4, 1 to the point 4, 0. How much did I actually change? Well, I could draw a line. I could draw a line there. And remember, when we talk about rate of change, how fast is it changing, we say how much, what's the change in y divided by the change in x? You know, how far did it change up and down over time? Okay? Well, what is my change in y? I went from +1 to 0, so that's 1. And my change in x, I went from -4 to 4, so that's 8. So my average rate of change over that interval is 1/8. But average rate of change doesn't have to be from endpoint to endpoint. Average rate of change can be anywhere. So I could say, what's the average rate of change from -3 to 2? Well, I started, what's my change in y? I started at 0, I ended up at 3, so my change in y was 3 in the positive direction, right? Ooh, see, I just caught myself, I messed up. Because this upper one went from 1 to 0. So we changed -1, right? So that should be -1/8. All right. So we went 3 positive, and then how far did we go over? 1, 2, 3, 4, 5. We went over 5, right? So our rate of change, our average rate of change, is 3/5, 3 over 5.